Okay, so we are on scatter plots, line of best fit, day one. The scatter plot shows the number of CDs in millions that were sold from 1999 to 2005. So here's 99 all the way to 2005. If the trend continued, about how many CDs were sold in 2006? So 2006 would be here. So what I always do when I have a scatter plot is I draw the best line of fit possible. So there's the best line of fit. Now what I can actually do is I'm going to do it the long way, and then we'll do it the short way, and then we'll do it the long way. That will always work. In 2006, my dot is going to be here, which is going to be below the 650 mark. So my value is going to be somewhere here. If I go ahead and I need to create my line of fit, my equation, I need to choose the best dots possible that are far away. So this one's a good dot, and probably halfway here, that's a good dot. So those are pretty far, and I'm trying to make them as easy as possible. So this is year 2000 in 900. So in year 2000, I am at 900. And in 2003, I am at, sorry, not 2003. Well, it's got to be in between. So I actually need, instead of in between, I apologize. Let's go 2004, and then that's halfway up, so that'd be 725. So 2004, 725. And you could have chosen something differently, but you're going to get something close to what I get. So my slope would be 725 minus 900 over 2004 minus 2000. 725 minus 900, that's negative 175 divided by 4. If I divide that by 4, I get negative 43.75. So that's my slope. So y minus my y-intercept, or my y1 is, so x1, y1 is 900. So y minus 900 equals my slope, negative 43.75 x minus 2000. And go ahead and distribute. Y minus 900 equals negative 43.75 x plus 2000 times 43.75. I get 87,500. Add 900. Add 900 plus 900. So I have y equals negative 43.75 x plus 88400. Now I have my equation. You should have something close to this. And now it says go ahead and plug in for 2007. So now I can plug the year 2007. So negative 43.75 times 2006. And then I'm going to add that to 88400. And I get 637.5. That is very close as an estimate. So what is slightly below 650? 637.5 is perfect. So if you have anything close to 650, you're right on track. Number 2, the table shows predicted annual cost for a middle income. Draw a scatter plot. So we're going to draw the scatter plot. So at 3, we're at 10,000. So this represents thousands. So we're at 10,700. So there's 10,700 is about here. 6 is 11,700. 9 is 12,600. 12 is 15. 15 is at 16,700. So if I drew a line of best fit, it would look something like this. So it really does go through the dots pretty well. So I'm going to choose this dot and this dot. So I'm going to choose the farthest dots. So y1 or y2 minus y1 over x2 minus x1. So 16,700 minus 10,700 gives me 6,000. And I'm going to divide that by 12. That gives me 500. Oh, but it says, sorry, draw a scatter plot and describe what relationship exists. This is a positive correlation. So they don't even tell me to find the line of fit. So I don't even have to do that. They just tell me. So it's a positive correlation. However you spell correlation. Okay. Number 3. Now it says, so make a scatter plot of the data, draw a line of fit. What is the equation of the line of best fit? So we have negative 2, 2, negative 2, 2, negative 2, 3, negative 1, 2, 0, 1, 1, 0, 1, 1, 1, negative 1, 2, negative 1, 2, negative 2, 3, negative 2. So, draw a line of best fit. That is a pretty good line of fit. So, I would choose this dot and this dot. So I'm at negative 2, 3. And I am at 3, negative 2. So it says, write the equation of best fit. So let's go ahead and do this. x1, y1, x2, y2. So this would be negative 2 minus 3 over 3 minus negative 2. So that gives me negative 5 over 5. So that would be negative 1. Let's see if that matches my slope anyways. Down 1 over 1, down 1 over 1, down 1 over 1, down. That's exactly what's happening to my line anyways. My y-intercept is at 1, so I already know what my line's going to be. My line's going to be y equals negative 1x plus 1. But let's go ahead and finish to prove it. So I got y minus, my y1 is 3. My slope is negative 1, x minus negative 2. So I got y minus 3 equals negative 1x minus 2, add 3, y equals negative 1x plus 1. It's the same thing that I got by just looking at my line. Here we go. The table at the right, so it says draw a scatter plot, the line of fit. So what am I going to count by? I'm going to count from 0, 1, 2, 3, 4, 5, 6, 7 on bottom. These are my study hours. My X's go on bottom. My grades are, so I'm going to skip. My smallest number is 60, so I'm going to start at 60, and let's count by 5s. 65, 70, 75, 80, 85, so 3 is at 84. 3 is at 84. 2 is at 77. 5 is at 92. So I got to keep going. 90, 95. So 5 is at 92. 1, 70. 0, 60. 4, 90. 3, 75. So if I drew a line of fit, it'd be something like this. These two dots would be very close to my line of fit. So 0, 60, and 4, 90. I would choose those two values. Now, if I estimated, it says draw a scatter plot, what's the equation of the line of fit? So that's what I'm on right now. So I already know that my equation, my y-intercept is at 60. So my y-intercept's at 60, and it looks like my slope is up 5, 10, 15 over 10, or 2. 15 over 2. That's what it looks like my equation is going to turn into. So let's go ahead and see if it matches. So I got 90 minus 60 over 4 minus 0. So that gives me 30 over 4. If I reduce this, that gives me 15 over 2, and I can change that into a decimal, which is 7.5. This as a decimal is 7.5. So we are actually going to get the exact same answer. So I'm going to say y minus, my y1 is 60, my slope is 7.5, my x1 is 0, so I get y minus 60 equals 7.5x. Add 60, y equals 7.5x plus 60. So those match. Predict the grade for a student who studied 6 hours. So hours is my x. So my x would be here. If I went up, they would be probably around close to 100%. But let's go ahead and check. So 6 hours, so 7.5. 7.5 times 6 plus 60 gives me over 100%. So that would give me 105%. And that's exactly where it looks like on my graph. Could this line go on forever? Shouldn't. This should not go on forever. It should stop at actually 100% is what it should stop at. So that is that's our day 1.